Chapter T Math class. And from this live class, I want to look at this topic, mathematics, which is indices. So we want to first, when we talk about indices, we are talking about index. And the word indices, we have index as the single. Okay, so that means in indices, we are going to be working with the power. That is the index number. So, and we have some laws of indices. We have laws of indices. So let's look at these laws one after the other. Okay. The number one law here. We have when we have a raised to power m times a raised to power n. This is going to give us a raised to power m plus n. That is, if we have two numbers that have the same base, their index here is not the same. So we only write one of the base, then we add the power. So for multiplication is addition of the power. That is that. For example, e.g., we might say we have 2 raised to power 6 times 2 raised to power 5. This is going to be 2 raised to power 6 plus 5, which is 2 raised to power 11. So that is how that works. Okay. So first, it must have the same base. The same base. Then once number with the same base multiply, we sum the power. So you know that first law. And also similarly, we have another one, a raised to power m divided by a raised to power n. This is becoming a raised to power m minus n. So for division of number which are of the same base, it's going to be the subtraction. This we subtract the index. E.g., we have a raised to power 12 divided by a raised to power 5. This is going to be a raised to power 12 minus 5, which is a raised to power 7. Okay? So for division, we subtract. Then, number 3, we also have, when we have a raised to power minus n. A raised to power minus n. This is called negative index because of this minus, called negative index. So this is going to be 1 over a raised to power n. So this law in indices is very important. This negative here is the one that become this reciprocal. Call this 1 over a raised to power n. So e.g., if we have 2 raised to power minus 5, write this as 1 over 2 raised to power 5. Okay? Now, when we have it this way, you can also reverse to this side. When we have it like this, you can write it like this. So we can reverse back all the law. So if we are given like this and we want it in this type in our solution and put it like that, so we can reverse it as well. Okay, so that is that. And we have number 4, a raised to power 0. This is 1. That's 1. That's law of exponent. When the exponent is 0, it is 1, no matter the number you have. So e.g. 5 raised to power 0 is going to be 1. Any number which is raised to power 0, it's same thing as 1. Okay, so let's look at number 5. Excuse me. Here we have a raised to power m or raised to power n. This will become a raised to power m times n, which is mn. So this power multiplies. It's multiplication. The power multiply. E.g., when we have 2 raised to power 3 raised to power 4. So now these two numbers here multiply and we have 2 raised to power 12. So that is that for that. Okay, so we look at number 6. And from here we have what is called fractional index. A raised to power 1 over n. This is fractional index. And generally this here we write it as n truth of a. N truth of a. E.g., if I have 9 raised to power 1 over 2, that's simply square root of 9. Because here, this 2, if you put 2 here, it's still same thing as square root. But if I have 9 raised to power 1 over 3, that will be cube root of 9. So that is that for this. Now, we can make it more general. If I have a raised to power m over n, this is no longer 1, but it's also a number. So this will now be n truth of a raised to power m. This raised to power m, you can decide to put bracket and put raised to power m. So e.g., if I have 9 raised to power 2 over 3, here it's going to be cube root of 9. The one down here is the root. So cube root of 9, which is now raised to power 2. Okay, so that is that. And also we have some other law. Let's call this number 8. We have a times b raised to power n. This is going to be a raised to power n times b raised to power n. This power will affect these two numbers, a and b. So that is what we have. So also follow this is similar to this. When we have a over b all raised to power n, we can also say that here we have a raised to power n over b raised to power n. So we also have the power here affecting these two numbers here. If you are joining us for the first time in this class, you are watching us here at Master T Math Class Live, and we are solving indices, looking at the topic indices. So do it to give a thumbs up. Also, stay tuned to the end of this class and follow us. Subscribe for more videos. Now, I want to look at some application question for this problem. Application for the law of indices. So we look at the application of the law. Alright, so let's look at the number one example here. Of example. Now, here we are to simplify into bracket 1 over 81 all raised to power minus 1 over 4. Now, when we apply the law that we know from the indices, first is to see that we have negative at this power. For the solution here now, this is going to be what is given, it is 1 over 81, which is all raised to power minus 1 over 4, and now be written as minus there is standing as reciprocal. Reciprocal means we interchange this fraction. So we can say this is 81 over 1 raised to power 1 over 4 now. I know, of course, 81 over 1 is still 81, which is raised to power 1 over 4. And interestingly here, this also follows a law that we can say this is 4 truths 81. And 4 truths of 81 simply mean the number you can multiply 4 times that will result to 81. That is definitely 3. So the result here is 3. Or from here, we can decide to say we have 81, or we have from here 81 is same thing as 3 raised to power 4. What is 3 raised to power 4? 3 multiplying itself 4 places, 4 times. So that gives us 81, which is raised to power 1 over 4 from here. And also when we have this power multiplies, this gives us 3 raised to power 4 times 1 over 4. Also from that law of indices. And definitely 4 here cancel each other. We have 3 raised to power 1, which is the same thing as 3. So whichever way we want it, just for better understanding. Okay. Now, the number 2 question here, we have also simplify 125 all raised to power brackets 125 raised to power 2 over 3. So solution here, this is just fractional index. So we have 125 raised to power 2 over 3. The law we apply is a raised to power m over n, which is same thing as n root of a or raised to power m. So just write this down. We have cube root of 125 or raised to power 2. Cube root means the number you multiply 3 times. I will give you what is inside here. So 5 is the number. So we multiply 5 3 times to get 125. So this is 5, then square. And 5 square is 25. So that's simple. Okay? That's simple application of the law. Alright. Okay. So we look at some other one. Let me give us this as activity to try. So and say the class activity now. Let's do this shortly. We have 27 over 8 or raised to power minus 2 over 3. So what's the answer to this? Then 2. Okay, let's do this one. All right, you can drop your answer in the comments. Drop your answer in the comments. All right, now when we look at this as well, we discover that we have negative at this power. We have negative index, and for the negative here is reciprocal. So to remove this negative, we find the reciprocal here. So we can change this as 8 over 27. Now raised to power over 3. Okay, now what this all mean is that we have fractional index just like this. You can say this is cube root of 8 over 27, which is raised to power 2. And what this one means, cube root of 8, that's 2, over cube root of 27, that's 3, then all raised to power 2. And this power of 2 affects 2 and 3. So that 2 squared, that's 4, and 3 squared, that's 9. This here we have this is the final answer to this. So we have already simplified the particular problem. Okay. So now let's look at another subtopic here. We call it simple indica equation. Simple indica equation. So we have some equation that has to do with indices. Simple one. So let's look at it briefly. We have simple indica equation. Now, example, solve for x. Let's look at number one. Examples one. Solve for x. 4 is to power minus 3x minus 3x equals to 1 over 64. Okay, this is an equation, simple one, that has to do with indices. And whenever we want to handle question like this, we make sure that we have same base on both sides, both on the left, excuse me, we have both on the left and the right hand side. Let the base have the same value. Now, this base 4 here, you can also write 64 as base 4. That this what is given, 4 is to power minus 3x equals to 1 over 64. We can then write it as 4 raised to power minus 3x equals to 1 over 4 raised to power 3. 4 raised to power 3 is 4 multiplying itself 3 times. So that will give us 64. Then, now look at this side here. We can apply that and reverse the negative index. Of course, when we have a raised to power minus n, that's 1 over a raised to power n. So this is what we have here. We can reverse it to have negative power. So we can then say that this is 4 raised to power minus 3x now equals to 4 raised to power minus 3. So this and this are the same thing. Just apply that law. Then now, when it is equation like this, you have equals to sign, and the base on both sides are the same. What we need to do is to remove the base now. You don't necessarily need to cancel, you just know that the base is out. Then we have minus 3x equals to minus 3. Just divide both sides by minus 3. Then this cancelled out. So we have x equals to minus 3 over minus 3, that's 1. So the simple answer here is equals to 1. So that is what we have for that. Okay. It's a simple indica equation. All right. So let's solve another one. Yeah. As number 2. Okay, so we have the second one. All right. When we have 2x plus 7 all raised to power 3 equals to 27. Now, we want to solve for x. Actually, this here is supposed to have 3 solutions. There will be a complex, there will be 2 complex solutions here in this problem. We want to solve it, okay? But now, just to find the, okay, when we solve this fully, we're going to have 3 solutions altogether. So there must be 2 complex and 1 real solution. Now we are going to find just the real solution here, which is how most people want it done, and how it is done at the level of grade, let's say 9, or grade 10, as is done at the level of grade 10. So here you can say this is x plus 7 all raised to power 3. 27 also can be written as a power of 3. So we can say that's 3 raised to power 3. Because 3 multiplies itself 3 times, that will give us 27. Then now look at the power. We have the same thing, so we can drop it out. And we have x plus 7 equals to 3. So taking 7 to this side becomes x equals to 3 minus 7. So here equals to x equals to minus 4. So that is the real solution we have there. So that is that for that, okay? And thank you for connecting with us live here at Master Team Atlas. You can lay your hands on this. Let me give us one question here. And we try it as a practice question. So we have practice. And practice this. And we have 1 as 9 raised to power x equals to 1 over 3 times 27 into bracket 27 raised to power x. So find the value of x. Find the value of x. And number 2, we have 3 raised to power x minus 4 equals to 234 squared. So also find the value of x. And thank you for connecting. Subscribe to stay tuned and see you next class. Bye for now.